For lesson 74, we are simplifying square roots. When we work with square roots, some of them may be perfect. If we talk about the square root of 81, we know that that's 9. The square root of 36 is going to be 6. But what do we do with square roots like 42, for instance? 42 is definitely not a perfect square root, but we ask ourselves, can we simplify something like that? So in this lesson, we are going to actually explain and demonstrate how we're going to break down these square roots into their simplified form. We begin by talking about the product property of square roots, which simply states if I have the square root of some number a times b, that is going to be equal to the square root of a times the square root of b. Okay? More concrete example. If I have the square root of 6, that is equivalent to saying that, okay, 3 times 2 is 6, so it's the square root of 3 times 2. And I can go even further to say that that is the square root of 3 times the square root of 2. This property allows us to break down these square roots into smaller factors. Okay? Understand this does not work with addition. For instance, the square root of 5 is not equal to 2 plus 3 and is not equal to the square root of 2 plus the square root of 3. It only works with multiplication. So all of these problems that we'll be working with is multiplication and looking for these factors. So let's begin with our first example, the square root of 12. Now if we look at the square root of 12, what we want to look for is perfect square root factors. Factors of 12 could include 4 and 3. 4 and 3, most definitely, when we times it, gets us 12. And the nice thing about 4 is that we know that the square root of 4 is a perfect square root. So as we break these apart using our proper product property, square root of 4 now becomes 2. So ultimately, the square root of 12 is equivalent to 2 times the square root of 3, or 2 square roots of 3. Let's look at another one. If we look at the square root of 8, factors of 8 would include 4 and 2. So 8 is equivalent to 4 times 2. We didn't really change anything there. Now we break up our square roots. And we recognize that, again, 4 is a perfect square root. So we have 2 times the square root of 2. Let's take a look at another one. Factors of 18. As we look at the square root of 18, we could say factors could be 3 and 6. So let's try that. 3 times 6. So the square root of 3 times the square root of 6. The only problem with 3 and 6 is they're factors, but notice neither the square root of 3 or the square root of 6 are perfect square roots. So we've actually kind of reached a dead end here. So let's go back. And let's try some new factors. Say 9 and 2. So we have the square root of 9 times 2. As we break those two apart, we have the square root of 9 times the square root of 2. And wouldn't you know it, that square root of 9 breaks down to 3. So we have 3 times the square root of 2, or simply 3 square roots of 2. So that's the process that we're going to be doing today. Now as we look at example number 1, we notice we're looking at the square root of 216. Now, the problem with 216 is it's a very, very big number. And to find factors of 216, it's most definitely we can. We know that 2 is a factor, but we don't know it's going to be simplified right away. So this is at the point where we really use method number 2 to simplify these. What we want to do first is start by doing the prime factorization of that number. So 216. If we look at the prime factorization of 216, we know that 2 is a factor for sure. And if we factor out 2, we're left with 108. 2 is prime, so we're done there. Let's go to 108. 2 and 54. 2 is a prime number, so we're done there. Now we're down to 54. 54 is still even. 2 and 27. 2 is prime. If we look at 27, Factors of 27 are now 3 and 9. And lastly, if we do 9, we have another 2 3s. So at this point, the square root of 216 is equal to the list of all of the primes that we have here. We have 3 2s and 3 3s. So there they are. And here's the point in the game that we need to pay close attention to. Now that we have the list of all of our primes, we have the list of all of our numbers up there, 2, 2, 2, 3, 3, 3. What we want to do is we want to put those numbers into pairs. So if I look at those lists, notice I have a pair of 2's here. So I'm going to box those together. And if you notice towards the end, I have a pair of 3's as well. Now I have a 2 left over and I have a 3 left over, but they're not the same, so I can't pair those together. So here's what we're going to do. We are going to take those pairs and we're going to put them in their own radical. Just like so. Same thing with this pair of 3's. Square root of 3 times 3. And then lastly, what we're going to do is take our leftovers, which would be this 2 and this 3, and we're going to put them in their own radical. So again, look for pairs, put them in their own radical, and now what we're going to do is we're going to go ahead and multiply. Now 2 times 2 is 4, 3 times 3 is 9, and 2 times 3 is 6. And what was the benefit of doing all that? Well, notice square root of 4 is 2, square root of 9 is 3, and the square root of 6, well, is just going to simply be 6. We can't break that down any further. And lastly, we're going to take 2 times 3 to get 6. So we come up with 6 square roots of 6. Let's try one more. If we look at square root of 210, start by doing the prime factorization. So we'll go a little bit quicker this time. 2 and 100. Actually, instead of going 2, let's go 21 and 10. 21 can be broken down to 3 and 7. And both of those are prime, and we're done. If we go to 10, we have 2 and 5. Very good. So at this point, we have the square root of 210, which is equal to the list of its primes. We have 2, 3, 5, and 7. At this point in the game, we went back and we looked for our pairs. Well, notice we only have a single 2, we only have a single 3, we have a single 5, and we also have a single 7. There are no pairs available for us. So what does this mean? There are simply no pairs, which means the square root of 210 cannot be simplified. So your answer is the square root of 210. Now this seems like a trivial example, but the point I wanted to make is that some square roots cannot be simplified. 210 is an example of that. If we scroll back up, 216, there we had our pairs, and therefore we were able to simplify. So there's a couple of examples for you to work off of. Do your prime factorization, list your pairs, box your pairs, pair them up, and then simplify from there. Practice set problems that I want you to work on are A, C, and G.